Good morning, everyone. Thank you for joining us today and welcome to Production Modeling Corporation's web presentation. Today's topic is Guide to FMEA Excellence, where we will discuss two parts, both Process and Design FMEA. This will be presented by Dr. Serhat Aaron. He's a Quality and Operational Excellence Advisor to PMC. On a housekeeping note, we will be muting all phones and microphones during the presentation to eliminate any background noise. So if you have any questions, please be sure to type those into the chat box and we'll address those at the end of the presentation. Before we begin, I'd like to do a brief introduction into PMC. Since 1979, PMC has helped over 700 companies by completing more than 8,000 performance-enhancing initiatives worldwide. It is our commitment to excellence that brought us to the point we are the largest independent industrial engineering services firm here in North America. Next slide, please. Today's session will be focused on quality and compliance, but PMC also offers its services in factory design, laser scanning, lean, and traditional IE services. If you're already underway with productivity improvement initiatives in your company or are wondering where to start, PMC can help you. PMC has worked with hundreds of businesses across all industries to improve their business's performance, and shown here are just a few of our current and repeat customers. Now, I'd like to turn things over to our presenter, Dr. Serhat Aaron, to begin our presentation on Guide to FMEA Excellence. Serhat, take it away.
Thanks, Brian, and good morning. Welcome to our webinar. So a quick agenda I put together. It seems lengthy, but it's really not. So what we're going to do is a little bit about myself, then objectives of the webinar. We'll get into the quality core tools from there, FMEA overview, its applications. Then we'll get into the DFMEA and PFMEA and some key points about DFMEA and PFMEA. So design, FMEA is failure mode and effects analysis and design. DFMEA is the design FMEA, and the PPAP is the process or potential FMEA. So we'll finish it up with some key points and common mistakes people usually make during FMEA development. And we're going to finish it up with PPAP elements for automotive and aerospace to show where FMEA fits in the standard. So a little bit about myself. Over 22 plus years of experience in automotive and aerospace. And I've worked as pretty much in a very cross-functional environment. My roles were in quality, operational excellence, continuous improvement, industrial engineering, lean, Six Sigma, program management, quality warranty, supplier quality, problem solving. Also, part of my life, I've done facilities maintenance, health and safety, environmental engineering. So I have held some positions very at a global level. Before this current job that I'm at Boeing, I used to be the global quality leader, working for a company where I had over 100 sites responsibilities overseas and in North and South America. So I work with many different customers. Some of them are Ford, GM, Stellantis, Toyota, Honda, Nissan, Mercedes, Benz, BMW, Volkswagen, and so on and so forth. And I also work for tier one suppliers. I do have, I'm certified in many of the industry standards. Some of them are IATF 16949, ISO 14001, OSAS or ISO 45001, ESTS 2020, VDA 6.3, my certified master black belt in Six Sigma and Lean, also black belt in Design for Six Sigma. And I've also listed here what subjects I actually train on. I think that's enough about me. I can move on. So the objective here today is that we're going to go over what FMEA is about and why it's needed, Design FMEA and the Process FMEA. The connection, the FMEA is part of the quality core tools. Again, the failure mode and effects analysis is a risk assessment tool used to identify and address the potential failure modes in products and in processes. So FMEA is an analytical methodology used to ensure that the potential problems have been considered and addressed throughout the product and the process development process. While we're doing that, we need to make sure that we have cross-functional team. It involves a cross-functional team. Again, it's about risk assessment. Critical and safety-related components of the process should be given a higher priority. It is meant to be before the event action, not an after the fact exercise. An upfront time spent properly completing an FMEA will minimize the late change crisis. Evolves throughout each stage of the design and manufacturing development process and may also be used in problem solving. And finally, it can be used in a non-manufacturing area such as analyzing risk with safety system. FMEA development, either design or process, uses a common approach to address potential product or process failure to meet expectation, potential consequences, potential causes of the failure mode, application of current controls, level of risk, risk reduction. Before the FMEA document is started, the team must define the scope of the project and collect existing information which is necessary for an effective and efficient FMEA development process. FMEA format may vary based on the needs of the organization and customer requirements. The format should at a minimum address the functions requirements and deliverables, failure modes when functional requirements are not met, effects and consequences of failure mode, potential causes of the failure mode, actions and the controls to address the causes of the failure mode, and finally, actions to prevent the recurrence of the failure mode. There's a system FMEA, which is made up of various subsystems, where the focus is to address all interfaces and the interactions among the systems, subsystems, the environment, and the customer. Examples of systems includes, for example, in a car, a chassis system, powertrain system, and interior system. The subsystem FMEA is a subset of a system FMEA, where the focus is to address all interfaces and the interactions among the subsystem components and interactions with other subsystems or systems. Example of a subsystem is the front suspension subsystem, which is a subset of chassis system. The third is the component FMEA. It is a subsystem of it's a subset of a subsystem FMEA. An example would be the brake pad, which is component of the brake assembly that is subsystem of chassis system. In FMEA, in automotive or FMEA in this type of world, there are four major customers to be considered in the FMEA process, and all need to be taken into account in the analysis. End user, this is the person or organization that will utilize the product. OEM assembly and the manufacturing centers or the plants. This is the OEM locations where manufacturing operations and the vehicle assembly take place. Supply chain manufacturing, the supplier location where the manufacturing, fabricating, or assembling of production materials or parts take place. And finally, the regulators. These are the government agencies that define requirements and they monitor the compliance to safety environmental specifications. The risk can be identified in three different ways: through severity, occurrence, and detection. Severity is an assessment of the assessment of the level of impact of a failure on a customer. Occurrence is how often the cause of a failure may occur. Detection is an assessment of how well the product or the process controls detect the cause of the failure or the failure mode. Management owns the FMEA process, selecting resources, applying resources, effective risk management process, process timing, eliminating roadblocks, and incorporating lessons learned. So where do we apply FMEA? FMEA technically can be applied on new designs, new technology, new process, product design changes, process design changes, new environment, new location, and new application. Okay, now let's get into DFMEA, the design FMEA. DFMEA is a structured method for analyzing the risk by ranking and documenting the potential failure modes in a design. The purpose of DFMEA is to assist in the identification of critical items as well as the design and the process key characteristics. It prioritizes action plans for mitigating risk and it also serves as a repository for lessons learned. There are many different templates, but I took this from AIAG manual. So you can see again, every company comes up with their, but let me walk you through quickly what should be included in the PFMEA. The DFMEA. There's two sections of this table or template. The top section, I call that the title block. And this is where we include everything about the product that we're analyzing, if it's a system, subsystem, or component level. Design, the design information is also included here because we need to make sure we're working off of the most recent or the latest design. There is also, some information about the program that it represents. If suppliers are involved, we also put suppliers information here. There's also DFMEA information where we need to make sure that the original date and the revisions are documented. That's the title block, the top section of the form. And then the bottom section is the requirements that we must have. So it starts with, we're going to have to track it with an item number. Then there will be a function. This is where we enter the intent functionality of the item being assessed. Then the requirement of that function. The next one is that we look at the potential failure modes of not meeting that requirement. And consider, in this case, we consider 5 types of failure modes: either full failure, partial failure, intermittent failure, degraded failure, and unintentional failure. From there, then those failure modes, then we need to define the potential effects. Here we list the effects for each potential failure mode as experienced by the customer. And again, you have to consider all 4 customers when you're assessing the failure mode. Then the classification. So there is a unique ID here. This is where we list if a feature or characteristics is a key or it's a critical items. From there, we actually start documenting the potential causes of the failure modes. So the next column, we look at the current design prevention controls, if any. If not, then you just put NA in there. Then we have the detection controls. This is where we list all current design methods used to identify the cause of the failure. In this case, some examples would be finite element analysis, qualification testing, fault tree analysis, tolerance stack up, and so on and so forth. That actually at this point now up to here, along including the severity, occurrence, and detection rating, severity occurrence, which is the criticality, and the RPN will be calculated. So based on the methodology that your organization will be using, for example, currently we're using RPN. We also look at the severity, 9 or 10 and high RPN. The top, we focus on top 5 or top 10 RPNs to be mitigated first, and that you complete the entire DFMEA up to here. Then, based on your methodology you were going to use in your organization, you're going to start taking some actions, and that's where the recommended action comes in. Here, we're going to list the actions from the cross-functional team to reduce the RPN or the risks. Here's a quick example of a DFMEA with cause, controls, and recommended actions. So it was about disc brake system, where the failure mode is showing itself as a vehicle not stopping. Potential failure causes of that are listed as mechanical linkage, brake due to inadequate corrosion protection. And technically, there is a prevention control which the product is designed per material standard, MS 8845. And detection control is the environmental stress test that the product is going through. But still, it's a high risk, and it was recommended that we change material to stainless steel. So that's how it works. And this is a quick summary of an example. So it doesn't talk about the RPNs and all that, but at the end, in order for you to focus on recommended actions, so you need to have the RPN or the severity being high so that you can actually react to that. I mentioned there are you have to actually identify what severity, occurrence, and detection ratings are. So we do have there are tables that can be used, well, should be used as the criteria. So if you look at the top, it says hazardous without the warning. So effect. Here, the potential failure mode affects the safe vehicle operation and or involves the non-compliance with regulation without warning. That's 10. And the 9 is the same, but at this time the you have the ability to at least get warning. So it's 9. The effect is very high when vehicle item is inoperable, loss of primary function. So that's 8. So going into this in more detail, but that's the criteria we're going to use to evaluate the severity rating. Then the occurrence, we have the ranking from 10 to 1, and 10, of course, is the worst case. Very high occurrence probability is very high. Persistent failures, which is greater than or equal to 100 per 1,000 vehicle items. 9 is 50 per 1,000 vehicle items. 8 is 20, and so on and so forth. And the last table has to do with detection. Detection, again, for 10 through 1. The higher the higher the number, the less the detection ability. So almost impossible, where design control will not and or cannot detect the potential cause, mechanism, and the subsequent failure mode, or there is no design control. Very remote, which is 8, 9. So very remote chance to design control will detect the potential cause. Remote is the chance to design the control will detect the potential cause and subsequent failure mode. Very low is chance the design control will detect the potential cause, mechanism, and subsequent failure mode. That's scored also 7. So using these three tables will actually have you be able to quantify the risk that you're dealing with. And some key points about DFMEA. Severity is associated with the most serious effect of a failure mode. It can only be reduced if there is a design change. Occurrence is associated with a specific cause of a given failure mode. It can only be reduced by removing or controlling one or more of the causes of a given failure mode through a design change. Detection can be associated with failure mode for detective and the cause for preventive purposes. Severity ratings of 9 or 10 must be reviewed regardless of RPN. High RPNs must be reviewed, and it's better to prevent a failure by eliminating its cause than detect a failure or a cause. The criticality number, the severity times the occurrence, highlights risk requiring preventive action. Use wording in descriptions to make cause effect logic apparent. Assume the design will be manufactured, assembled to the design intent. Design for manufacturability and assembly concerns may be included in the DFMEA if they have contributed to or been responsible for past failures. Okay, that's what I want to talk about DFMEA. Let's get on Process FMEA. A quick overview. The PFMEA supports manufacturing process development in reducing the risk of failures by identifying and evaluating the process requirements, identifying and evaluating potential process related to failure modes, the effects of the potential failures on the process and the customer, identifying the potential manufacturing or assembly process causes, and identifying the process variables on which to focus process controls or occurrence reduction or increased detection of the failure conditions. The PFMEA is a living document and should be initiated before or at the feasibility stage, be initiated prior to tooling for production. Take into account all manufacturing operations from individual components to assemblies. Include all processes within the plant that can impact the manufacturing and assembly operations, such as shipping, receiving, transporting of material, storage, conveyors, or labeling. This is a template. Uh, I just realized that I missed out the title block. So the PFMEA also has a title block very similar to the DFMEA. Again, for the same purposes to make sure that we know what design that we're working off of and so on and so forth. We also have the traceability for the original PFMEA and the revisions. Um, as you can see, this template starts with a process step, and then the process description and requirements. Here we list the requirements of each process step. If there are several requirements, then we separate them into individual rows. Then we look at the potential failure mode. This is where we list where the process could fail to meet the requirement for each requirement. So we consider the 5 types of failure modes, either full, partial, intermittent, degraded, or unintentional failure. Then we look at the potential effects of the failure. Classification, very similar to DFMEA. We define here if that characteristic is a key or critical item. Potential causes of each failure. Again, in this case, if there are multiple causes, we actually split this into multiple rows. Current process prevention controls, we list them in this column. Then the detection controls. So we have prevention controls, detection controls, if any. Again, if we don't have any, then we put NA. Just similar to DFMEA, up to the RPN column is when we complete the entire PFMEA. And that point on, again, we're looking at either high RPN, so we focus on top RPN, and severity of 9 and 10. And from there, once you have the top RPNs failure mode or the cause of the failure mode identified, then you have to use the recommended action column to list the actions to reduce the risk. There's more steps here that I didn't talk about them in DFMEA. The next are like we definitely need to place a responsibility. This is not an organization. Here you have to provide a name, a target date, and the actions taken as per the recommended actions, and the effective date. So you're going to have to monitor your recommended actions implementation for a while, and then you're going to have to reassess your severity, occurrence, and detection based on the recommended actions. Then will be your action result in RPN. So the expectation is that you have to reduce the RPN that you started with through the recommended actions. So similar to the DFMEA, we have tables for severity. Again, I'm not going to go over these as part of this webinar here, but there is a table for occurrence and table for detection. And each um, rating is from 1 to 10. So the RPN that we're talking about is a product of severity, occurrence, and detection. So the maximum RPN you're going to get is 1,000, and the minimum is 1. And a couple of examples here, the one of them being from a reflow oven, your process number and the description. It's process number 70, description is reflow oven, bottom and top side surface mount technology process, terminal flow, and the lead-free solder only. And the failure mode here was defined as the fracture solder joint, cold solder, inefficient reflow, do adding, and so on and so forth. The potential effects, functional failure or field failure could happen. Joint does not meet the IPC requirement, and production quantity and dollar loss. The cause would be the incorrect oven profile or machine setup, or potentially preventive maintenance not done on it. Current process controls, there are work instructions for employees to follow, setup sheets. There is a KC profile and the parameter sheets that are being used. The detection control they have is a first article inspection, visual inspection, work instructions, and again, the monitoring in line, the AOI. And again, this one over here, if you look at the severity was 6, occurrence 1, and detection 3, so the RPN was 18. In this example, they didn't react to this because the team believed the RPN was low enough, so risk was very minimum. So some key points about PFMEA. You must conduct PFMEA timely and quantify the risk using RPN, mitigating the manufacturing process risk, and assume the product as designed will meet the design intent. So when you're doing, and actually similar thought process is valid for DFMEA. You're going to have to assume that the process, the process will do what the product is intended. So failure modes can relate to products, defects, non-conformances, or process non-compliances. Effects can affect the operations, subsequent operations, customer operations, as well as the end customer. Occurrence cannot be reduced without changing the design or process to decrease the chance of failure. The FEMAs and the PFMEAs are living documents and should be revisited and updated as new information and the results are obtained. Avoid overanalyzing or underanalyzing. Scope FMEA correctly. Make sure the lessons learned are used as input to PFMEA. Make sure to modify the process control plans after mitigation actions are implemented. DFMEAs and the PFMEAs will be performed ideally with members who are common to both teams to facilitate the concurrent design build efforts. Some common mistakes: restricting to only one potential failure mode or potential failure effect or potential cause, assuming that because of failure is detected, its severity is less. Single person creating the FMEA, not revising FMEA after it is created, not involving the right multidisciplinary team, not having the members common to DFMEA and the PFMEA teams. DFMEA does not provide effective recommendation for improvement. Design verification plans not modified after recommendations are implemented. Missing interfaces. Disconnect between information from field and the DFMEA. Overanalyzing and underanalyzing effects and the causes, initiating conducting the DFMEA late. Incorrect procedural sequence or for scoping of DFMEA. PPAP elements. So this is where I wanted to point out there are 18 PPAP elements. The PPAP is an output of APQP, and it stands for Production Part Approval Process. As you can see here, the design failure mode and effects analysis, DFMEA, and the process failure mode and effects analysis of PFMEA are required PPAP elements in automotive. And also in aerospace, AS 9145, they are listed as design risk analysis, and the DFMEA is a tool that is listed there, and also the PFMEA is listed so these are 2 of the 11 required elements. And that brings me end of my my webinar, and I would like to thank you for attending. I would like to turn it over to Brian.
Yep, thank you, Sirhat. So with that, we'll end into the Q&A session. So if you have any questions regarding the presentation or any specific questions you might have pertaining to FMEA or quality in general, please go ahead and type your questions in the chat box. Sirhat, we did have a few questions come in during your presentation, so we'll get started with those. But please, like I said, if you have any questions or any of these questions spark questions of your own, please use the chat box. So Sirhat, the first question we had is why is FMEA required?
Well, I guess the question came before I finished up the last 2 slides there. So FMEA is, if you look at it from a PPAP point of view in automotive, it is so DFMEA and the PFMEA are required PPAP elements in automotive, and also they are required in the aerospace 9145 standard.
Right, thank you, Sirhat. Another question we had, when developing a DFMEA, do we always consider the end user?
Did you say D or P?
D.
Okay, it really doesn't matter. Yes. Remember I mentioned there are 4 customers that we must consider when we're doing either D or PFMEA: the end user, the plant, the suppliers, right, and the regulators. So, and when you're for each failure mode, you must consider those 4 potential customers, and making sure that we are using the most significant effect when we're again we need to list all the effects on each customer type, but then to take it further in the risk assessment, we need to take the most significant effect, so that way we're not over analyzing, which is one of the common mistakes that people do.
Thank you, Sirhat. The next question we had, can a PFMEA be done without or prior to a DFMEA, and is that recommended?
Well, the answer is yes and no. the reason why I'm saying that, because if it's an existing product and you're launching something very similar, you could technically use the existing PFMEA as the lessons learned. But from the product life cycle point of view, if you think of it as you're launching something new, you must actually consider your design FMEA first. Because again, you need to make sure that your product is meeting the design intent. And that's one of the assumptions that we make when we are developing PFMEA. So, and through this mitigation risk assessment, through this risk assessment tool, the DFMEA, what we're trying to do is to make sure that product is meeting the design intent. And then we focus on the process. So in a way, I think I'll say 90% of the time you're not going to want to work on PFMEA first. So you want to have to make sure that your product risks are identified and assessed before you start focusing on your process.
Okay, thank you, Sirhat. Another question we had, do we have to come up with recommended actions for all failure modes?
Then you would be spending millions of times and you will never end up finishing or even baselining your FMEAs. The answer is definitely not. Over time, you're supposed to be review and address. You may actually look at, well, again, the methodology that you're going to, or strategy that you're going to be, your organization is going to be using may be different from company to company. I worked for tier one supplier where we had a threshold number with RPN. It was 120. I worked with somebody else whose threshold was RPN of 80 or higher had to be addressed. But then I worked and currently where I am, we do not use any RPN threshold. So what we're trying to do is focusing on the top risks. Like that's why I mentioned top 5 or top 10 in the PFMEA and in the DFMEA, the same. And we try to mitigate those. Once we are done with those top 5, then we go to the next top 5, then the following top 5. The idea is, again, ultimately you go around and touch base on every one of those failure modes throughout the production, right? The program lifetime. Um, and there may be cases where you're going to get on again, as I shared one of the examples, you will have an RPN RPN is about risk, right? You're quantifying a risk. You're going to come up with a decision where you're going to decide not to do anything about a risk that is acceptable to you. So I hope that answers that question.
Thank you, Sirhat. Another question we had, is it a common practice that some of the process failures can be overcome with design changes?
Definitely. I mean, the we don't. So whenever you realize there's a failure mode, and the cause of those failure modes, the most common approach is that we try to prevent it from happening. That should be your number one priority. Adding additional detection is not going to get you or minimize the risk uh, where how you want it. So for that, you may want to you want to be focusing on the prevention controls. For that, you need to either redesign your process or add some error and mistake proofing devices built into to your process.
Thank you, Sirhat. I don't see any further questions coming in at this time. So with that, we'll close the Q&A session. Thank you for answering those questions, Sirhat. For a schedule of upcoming topics, please be sure to go to our website at www.pmcorp.com and click on the resources tab to register for other webinars. Also, as someone asked in the chat box, there will be a recording of this presentation and then it will go up on our YouTube channel either later today or early tomorrow. If you want to go check that out, it'll be on our YouTube channel. That's PMC Videos. That's videos with an S and all one word. There are for other topics interested in your team, and obviously a recording of this presentation. But with that, that'll conclude today's webinar. I'd like to thank everyone for your participation. If you think of any questions coming up, be sure to submit an inquiry to our website or contact us in the address now on your screen. We look forward to working with you or perhaps joining you in another one of our webinars. Thank you and have a great day.
Thank you. Bye, everyone.